Right, nice. So, in the last set of classes last week, we started off section 5, right? So section 5, wait, wrong second. Uh, bring this thing here. Right, it should be seen this here. Um, so in the last week, we started off section 5 here, right? Um, so we spoke about security fundamentals, and we went through from the very basics some key security concepts that you will need to know not just for the CCNA, but for Security Plus and CEH and all these other big security courses. These base concepts will be very important for those sorts of things. But even network engineers now need to understand, what is a threat and what is a vulnerability and an exploit and physical access control and all of these things. Because in any data center that you go into, you're going to be faced with these things because security affects everybody right now, and in the in future as well. This section is just going to keep growing, which is why Cisco dedicated a whole section to it. So we went through the key security concepts. We went through program elements. Um, so just what you should be doing in your organization. We went through configuring local passwords, and we said you should never use the actual password word in Cisco. You should use secrets, and we showed how you could just crack a regular password in Cisco, or even if you use the service password encryption command, you could just break that password very easily. But the secrets, the local secrets are a lot more secure than those passwords. We went through some security password policy elements, management complexity, and password alternatives. Um, so we went through what is multi-factor authentication. So remember I said the most secure systems are those that draw from multiple factors, and even if you use like a username plus a password, that is still not multi-factor because it's from the same group. And we mentioned things like something you know and something you have and those sorts of things. So you could draw 5 elements from the something you know category, and it's still not multi-factor authentication because you need to mix those groups. You need to do something you know and something you have, or something you know and something you do. And that's the most secure way, at least as much as we know right now. That is the most secure way to authenticate users, which is why we have this large burst of stuff like fingerprint readers on phones, and digital signatures and all of these things. We also covered certificates, so you'll see certificates used in like right here. You see, connection is secure, certificate valid. So you can see show certificate issued by somebody. And that's why we have a lock here, because we have verification with some sort of digital certificate here, and we could tell we are actually at learningnetwork.cisco.com. We expect it to be owned by Cisco Systems. No scene. This is a CA that they recognize to. Expires on 2022. Okay, so this is still valid. And we could go through here and see a bunch of other interesting details if we care to validate this website. So we can see how that's useful. And well, of course, biometrics. We all know about fingerprint readers now, and I showed you that biometrics could get really intensive. And in high security organizations, you'll see biometrics get a lot more interesting. Rather than just fingerprint readers, you could have iris scanners and whole palm readers and all these things. And then we discussed remote access and site-to-site VPNs, where we said you could use the internet as the backbone infrastructure, but then you set up tunnels over the backbone infrastructure to link your private networks together. So we see this used a lot right now, where we have people working from home and they're still allowed, or they're still able to access their private services in the workplace. So they could have their own private network at home, and they could have their own servers and everything else at home. But using this VPN, they could connect into the servers at work and access the exact same services that they were able to at work. So just as an example, I could use my work laptop at home, connect to my VPN at work, and use the work printer. I could send a document to that work printer, and it will print from my laptop at home, and I could tell somebody in the office to collect it, just as an example. And we could also interconnect branches like this, entire branches of users or employees, we could connect them over regular internet connections, so that we could have a branch in Chaguaramas and another branch in Mayaru, and they would behave as though they had a physical wire between them or one circuit between them, just using these site-to-site VPN tunnels. So that's as far as we got in the last class. So we're about halfway into security fundamentals. So we should have a fairly strong foundation now. And what we're going to do today is cover two fairly heavy topics. I would say in this entire section, these two topics here are the heaviest. Sorry, these 5.6 and 5.7, access control lists and layer 2 security features. So they're the heaviest for me in terms of they actually configurations, and they kind of technical. The other ones weren't as technical because they were mostly descriptions and definitions and stuff. These are a bit more high draft, so that's why I dedicated a whole class to them. And once we finish this, next week we'll finish out these last three topics, which should be fairly light, and then we'll get into the super new section, which is automation and programmability. And you'll see why a lot of people intimidated by this section. But it's really fun, and I am very familiar with all of these things, so I'll show you how easy these things are. It's just because they knew a lot of people intimidated by them. Right, so let's get started. Yeah. Okay, right, I haven't seen any messages yet, so I assume you all hearing me and seeing me properly. Pointers. Right. So yeah, as normal, let me know if the slides stick in or if you can't see the pointer or anything. If you have any questions as we go along. So 5.6, configuring and verifying ACLs. So now let's move on to our first configuration topic for today, access control lists or ACLs. So we mentioned ACLs before, right? I was waiting until we got to this topic to really dive into them because I didn't want to confuse you too much. But if you recall, we mentioned them in NAT rules. When we discussed NAT, we said we could set up a pool of IP addresses, and we could NAT an entire pool of IP addresses to a single public IP address. And access control lists, or ACLs, were how we did that. We set up a rule that said, like, this is our pool of private IP addresses, and this rule would match all of the addresses in that pool. And that same concept is what we're going to explore today. And you'll see how versatile and useful ACLs can be. So access control lists are basically lists of rules allowing or denying certain traffic, from certain networks, hosts, or protocols or applications based on the rules that we place in them. So basically, when you hear about an ACL or an access control list, just think of a list of rules. And on the very next slide, I'll show you an example, because I know the first time I heard about ACLs, they sounded really cool and really useful, but I couldn't actually picture them or see how they were used before I actually saw an example of one. So bear with me for this slide, and you'll see an example like immediately. So ACLs are processed from top to bottom and are executed as soon as a particular rule in the list is matched. So if you remember in section 3, when we talked about routing tables, I said that a packet could match multiple rules. And what happens is that if a packet matches a rule, the router will still go through the rest of the list in that routing table, or the rules in that routing table, and it will look for the longest match. Remember we said, a packet could match a /24 rule and then a /32, and it would choose the /32 because it was more specific, or it matched a longer route there. So that concept is completely flipped with ACLs, which is why I wanted to make this point here, because I know when you're thinking routing tables, you're going to think that. With ACLs, the rules are executed as soon as a particular rule in the list is matched. So as soon as you match something, as soon as the router sees, hey, this packet kind of matches this rule here, the router going to stop processing and it's going to send it out one time. It's not going to look through and say, oh, it matches this rule, but it also matches this rule, and this one a little more specific. No, as soon as it matches, it's going to go out. And they're going to say, okay, we started from the top. So they say the first one was rule 0. If you match rule 0, that's it. Go ahead. Don't worry about going to rule 1, 2, and 3. It's executed as soon as you match a rule. Whereas with routers, even if you match that default route, it's going to keep going. It's going to keep going and figure out what's the longest prefix that you match, or the most specific route that the packet will match. But ACLs, nah. So if a packet makes it through an ACL without matching any rule, then it is discarded by the implicit deny all rule at the bottom of ACLs. So that's the other big concept to understand in ACLs. So is a list of rules, and as soon as a packet matches any rule in the ACL, it's going to stop processing and it's going to go out and match that rule. The second thing is that if it makes it through the entire list of rules or the entire ACL, there's an implicit deny all rule at the bottom of the ACL. So if you go through the entire list and you don't match anything, then you're going to be dropped implicitly. So implicitly means you're not going to see the rule there, but it is there. So if you have, let's say, 10 rules in your list, you actually have 11. The 11th rule being that hidden deny all rule at the bottom, which will say, drop this traffic or block this traffic or deny this traffic in ACL terms. So ACLs can be broadly categorized into two groups, standard and extended ACLs. So you have a group called standard ACLs and a group called extended ACLs. Standard ACLs can be used to filter and identify traffic by source IP address only. So remember, a packet has this complicated header, an IP header, and we showed some of those headers, right? Source IP address, destination IP address, time to live or TTL. They have a bunch of other things in there, but standard ACLs only look at that source IP address. So what host machine are you coming from? That's it. That's all they could examine. They can't examine anything else at that IP layer. So these source addresses can be single addresses or entire networks and can be applied on either incoming or outgoing interfaces to filter traffic coming into or going out of a device respectively. So even though we could filter only by source IP address, where you implement the ACL really controls the direction. So if you put it in an incoming interface, you'll see it matters, and it's very different than if you put it on an outgoing interface. And if you really look at the packet flow and see where packets are going to hit this ACL, you realize that more than writing an ACL and developing the list of rules, figuring out where to apply that ACL or where to apply that list of rules is almost as important. Because whether you apply it to an incoming interface or an outgoing interface for your expected traffic will determine whether your IP address is a source IP address or a destination IP address, just as an example. So it might just not match any rules because you put it on the wrong type of interface. Right, so I promised you that you would see an ACL, and this is what it looks like. So you see this R1, and to see our ACLs, we do show IP access list or just show access list. So it gives us the same command. I usually prefer this one, and you'll see the different configuration commands that kind of match up with it, and you'll see why I prefer this one. But both of them will give you the same thing. So you see extended IP access list, and this is the name of our access list here. So you see 10 permit ICMP, and then network address, wildcard mask, and then any. So we'll get into this, right? But I'll just do a quick overview of this. So you see 10, 20, 30, and 40 here. These are the rule numbers or the sequence numbers. So remember, I said your ACL, well, any ACL order matters. So if a packet comes in here, it's going to hit 10 first, then go down to 20, then 30, then 40. Then remember, I said there's an implicit deny all rule here. So there's one that's kind of 50. It is not really 50 because if you put something else here as 50, it's going to be dropped down to 60. But just remember, it's always at the bottom there. And it means if you reach here, then be dropped. So that's the first thing. It will go through this top one first, and then go there, and then go there, and then go there, and try to match all of these. And if a packet matches this, it's going to go out. So just think it's going to match this rule, and then head out this side. And it's not going to go down here because it's going to match the first one. And then you have certain keywords you could put at different stages in the ACL, and that's where it gets complicated. So you'll see this rule is 1, 2, 3, 4 words. This one is 1, 2, 3, 4, 5 words. And then 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8. So you see there's no fixed number of words that you could put in here. If you're trying to learn the commands before, you might have memorized, you put in these 3 words and you press enter, and that's the command there. ACLs are a lot more tricky to learn like that. And that's what confused me when I first encountered ACLs, right? So the easiest way to learn is just to go in a command line or go in a router and press a question mark, and you'll see. So the first word here usually is permit or deny. We don't usually put in this number. Just to start off, we ignore this number here, and when we go in the access list, we put in the words permit or deny. And then you'll see we could put in a protocol here. So ICMP, I told you, was a special protocol before. And then you also have just regular IP or TCP. And then you could put in either any to match all ICMP traffic, or you could put in a particular network address and a wildcard mask to match, only packets from this network. Right, so I hope that kind of making sense now, and now you kind of seeing how it works. So permit or deny means the opposite, right? So if you permit a packet, you want to say, okay, I want to allow packets that match this. If you deny a packet, you want to say, okay, I want to deny packets that match this, or drop packets, or destroy these packets, however you want to think of it. So that's the two big options there. And then you say ICMP or IP or TCP or any. And say I want to deny or permit these types of packets only. So maybe I want to deny only ICMP packets. Then here is your from, and here is your to. So this will be a source IP address, and this will be a destination IP address. So I could do this one here because we have the full thing there. So permit IP. So we're going to permit IP packets that come from this network, which is categorized by this network address here and this wildcard mask here, and are going to this network, which is this network address here and this wildcard mask here. So you could kind of see how it being put together now. And with the any keyword, we say I want to deny all ICMP traffic that comes from any network and is going to any network. And here you'll see they want to permit ICMP traffic that is coming from this network there and is going to any network. Right? So I hope that's starting to make some sense. And just in case this might help you tie it together, you can see why this needs to be before this, because we're going to implement this list top down. We're going to start watching this list from here and then process here and there and there and there. If we say we're going to deny all ICMP traffic from any network going to any network, and then we say we want to permit certain packets, then if we put this on top, all ICMP traffic going to match this and be dropped, right? If we put this below this, then nothing is going to match this because all the traffic is going to be hit this rule and be dropped. Whereas with this, we want to permit certain packets, but if you don't match this rule, which means if you're not ICMP traffic coming from this special network here, then we want to deny it. So you can kind of see how ACLs will be useful now. And this is just the show command. So this isn't showing you how to actually construct the access list. This is just an access list that I wanted you to show to give you an example of what it looks like. So now let's get into how to actually make something like this. So ACLs can be identified by a number or by a name. Standard ACLs can be numbered from 1 to 99 or from 1300 to 1999, or can be named as we deem appropriate. So this is a normal Cisco question, which is why they keep asking it. What are the range of numbers of standard ACLs? So just memorize these numbers. Obviously, named ACLs make much more sense, right? Let me see, what was the name for this one? Okay, this one was just named example ACL because it was used as an example. But in the real world, we might want to say, okay, I can't really. Okay, yeah, it might be named like Protect Router R1 Management. So Protect R1 Management, because ICMP traffic is usually used to attack certain routers or public-facing devices. And then, if you remember SSH, I said SSH was using port 22, TCP port 22, and we want to allow SSH access. So just from my experience, I can tell you this is like a common access list you would put to protect your management interface or your management of your devices. But the point is, you want to name your access list to something that makes sense, right? If you name it ACL1 or ACL 2020, you don't really know what the ACL is supposed to be doing. So you're just reading through these rules and trying to formulate something in your head. If you name it Protect R1 Management, then you know, okay, this ACL somehow protecting R1's management interface, right? And then you read the rules and they say, oh, okay, that's what we're doing. That makes sense. So usually, I always say put well, name your ACLs appropriately. So we configure standard ACLs using either the command access list and the number, and then permit, deny. Oh, right. So I have the next command here. So you could use this command. So access list and then the number, and then permit, deny IP address and a wildcard mask. Remember, we do have the option to put anything else here because we said standard ACLs can only permit or deny based on the source IP address and wildcard mask. You can't do anything with the destination IP address and wildcard masks. So that's the big limitation of standard ACLs. And remember, we said this is the basic formatted rule, right? So you put in access list 1, for example, and then you start painting rules one time. So you say access list 1, permit 192.168.1.0, and then your wildcard mask for that. And that's a rule. And then you just keep repeating that command for the rest of the rules. And I'll show you an example of it just now. So for each entry or rule that we want to enter, we re-enter the above command multiple times. So we just basically press the up key. If you learned that from your labs, just press the up key and you'll see you have most of the old command saved there. You just edit that and put in, your first command was permit 192.168.1.0. Maybe a second command will be deny 192.168.2.0. This is the example. And then you keep doing that and you build your list like that by entering this command multiple times. Access list 1, permit, deny, whatever, whatever. Access list 1, permit or deny, whatever, whatever. Access list 1, permit, whatever, whatever. And we keep going like that. Now we can also use the command IP access list and name or number, and then enter our entries in the new configuration menu from the ACL for the ACL in the form permit or deny, IP address, wildcard mask. So again, this is the way I prefer. So you just go config T and then put IP access list and your name or number. So IP access list protect R1 management, and you press enter. And once you press enter there, you'll get into a sub configuration menu or a new configuration menu. And then there, you just repeat your commands. So you put in permit 192.168.1.0 and your wildcard mask, and then deny 192.168.1.2. 2.0 and your wildcard mask, and you keep going like that. And when you finish here, you just type exit. So this is my preferred way, but you could also just go config T and keep typing this full command for the full thing. Access list 1, and you keep going like that. So 2 different ways to create the same standard ACL. So you see config T and you just start typing. Access list 1, permit, access list 1, permit, And you see this is a whole network and a wildcard mask. This is just one host. So remember when I was describing wildcard mask, and I showed you the little cheat to calculate it. But the whole idea is where you have zeros, you need that to match. So the packet has to start with 192.168, and then where you have your 255s, it means it can be anything. So this 0 and this 0 doesn't need to be 0 and 0. It could be 0, 1, 2, 3, 4, 5, 6, 7, 8. So it could be 192.168.254, for example, and it would still match because that matches the wildcard portion of this wildcard mask. And you could contrast this with this exact host address here. So when you put the word host and you put an IP address, it means this is a single host machine. If you come in with 192.168.1.30, then you'll match this. If you come in with 172.168.1.31, you're not going to match this. We're only matching one specific host here. Whereas here, we're matching a whole network. And then you could always put your access list 1, deny any. So remember I said we have an implicit deny rule at the end of the list. You'll see at the end of this section, I'll show you why you want to put this. So basically the rule is always put in an explicit deny all rule at the end of the list. For now, you could think of it, well, the big advantage here is that you'll always remember that this is what will happen. If you don't have this, you might be thinking, okay, I'm permitting this, but I don't really know what will happen if you go through the whole list and they don't match. If you put in this, you'll know, hey, if I don't put in a list or a rule on top of this, then it's going to match this and it's going to deny all the traffic here. So this will help you to remember what will happen if you go through your whole list and you don't match anything. And then of course the next way to configure this exact same thing is type IP access list 1 or a name here, then press enter, and then put permit and a network, permit and a host, and then you deny any. Yeah. Let me know if you're confused or stuck anyway as we're going along, because I know ACLs really confused me when I first saw them. That's why I'm trying to give you a lot of examples. So that's half the equation, right? All we did so far was build an ACL using these rules. So our ACL so far has 3 entries, and that's it. It's just a list with 3 entries that either permits or denies traffic based on these rules that we supply. So then, to actually apply our ACL, we use the command IP access group and the ACL name or number in or out under an interface. So just as an example, we go config T and then interface GI01. Just as an example, you can do it under any interface. And then the command you put in is IP access group, ACL name or number, and in or out. So the in means I want to scan traffic that's coming into this interface. The out means I want this to filter traffic that's going out from this interface. So you can kind of see how that's important now, right? Just as an example, if you have this 192.168 and we have this big 255.255, so this whole 192.168 block, if we expect that we're going to connect into our router using this block, so for example, when we connect to the Wi-Fi, maybe we get a 192.168 address, and this is the interface that we expect that management traffic to come in from, then we want to put this ACL on the inbound side, right? We expect traffic to be coming from our management, well, from our laptops into this management interface. So we put this filter in. If we want to pay it out, we put IP access group 1 out. But in this case, out would be wrong, right? This is our management IP. This router won't actually be using this IP address for anything. We want our management traffic to be coming into the router, or we expect our management traffic to be coming into the router. So we want to put this inbound. So you can see now how putting this in or out could drastically affect what happens with the ACL. So we could have this ACL written correctly, but if we put it on the wrong direction, then the whole logic of it will be twisted. So this is just an example, right? So we see access list 1, permit this, and then interface S00 there. Right, so you have a S00 there, and then IP access group 1 out. So we're filtering traffic going out of this interface. Right, so you see we permitting 192.168.10.0. I know the text kind of small there, but it's 192.168.10.0 with a wildcard mask of 0.0.0.255, which is a /24. So we're basically matching this /24 here, right? You see 192.168.10.0/24. This is that network in wildcard mask form. So we're saying we want to permit this traffic to go out this serial interface. So we're filtering traffic going out this serial interface, and all we put in this access list is access list 1 permit this traffic here. So what do you think is going to happen there? We are allowing this traffic to go out this serial interface, but we didn't define anything for here. So what will happen when this guy tries to go out this interface? Remember that implicit denial rule? So he's going to hit this implicit denial rule and he's going to be dropped, because all we had was a permit list to match this traffic going here. So this guy has 192.168.10.10. This rule will match that, right? 192.168.10.0, and the wildcard mask is on that last portion. So the last portion could be anything. So that 10.10 matches this first rule, and that's a permit. So it's going to say permit, go out here, no problem. But this one is 192.168.11.10, and there is no permit rule for this. There's only that implicit deny rule, which will match everything that does not match this first rule. So therefore, traffic going out here from this guy is going to be dropped. But because we only put this as an outgoing rule on this serial interface here, so think of it as right here, then traffic that comes in here and goes out here is not going to be affected. So this guy could go here and ping anybody here, no problem. But if he tries to go here and ping out this side, when that traffic is going out there, this ACL is going to kick in and it's going to be dropped. So yeah, follow that example. Any questions about that? This is a fairly straightforward example for how an ACL could be useful. So just as an example, maybe this could be access out to the internet, and this is maybe a team in the organization that we don't want to give internet access to. We want to allow them to talk to their peers in this other office, but we don't want to allow them access out to the internet. Just as an example. All right. So assuming we all on board with this basic ACL example. So when using standard ACLs, we should aim to apply these filters as close to the destination network as possible to prevent filtering unwanted traffic through the filter. So standard ACLs filter on source address, so they can only filter traffic based on their source address, but we want to apply them as close to the destination network as possible. Because think about it here, right? This access list didn't allow these guys there. So when we put it going out here, we have no problem, right? They're still allowed to communicate here. And the whole purpose of this was to deny them access to the internet. But what if we took this same ACL and put it on this interface here, right here? Then it's going to match the same ACL as we expect, but it's going to be dropped by that standard implicit deny rule, right? And then any traffic that's going out here is going to match that denial rule and it's going to be dropped. So therefore, they won't be able to communicate to this network here. So typically, we want to put it as close to the destination network as possible. Because we don't want to filter traffic that we didn't intend to filter, basically. So now let's expand our knowledge a bit with extended ACLs. So that was standard ACLs. Standard ACLs only match that source IP address and source network address. See, we have nothing at the end here. We're just looking at that source IP address, where you're coming from. Now, extended ACLs can do a lot more. Extended ACLs can be used to filter traffic not only on source IPs, but also by destination IPs, by protocols, and by port numbers. Extended ACLs can be numbered from 100 to 199 or from 2000 to 2699. Again, just something to memorize. Always use names if you can. They can, of course, be named as well. Like standard ACLs, the extended ACL can be initially created using either the access list and ACL number or the IP access list extended and ACL name or number. We could use either of those commands just like before. Each entry in our extended ACL then follows this syntax: permit or deny, protocol, source IP address and network, and then destination IP address and network. So just like I said, here we only have the source IP address and the network. Now we're going to put source IP address and network, and then destination network, IP address and network. If we specify TCP or UDP as a protocol, we open up some more options. Permit to deny, TCP or UDP, and then source IP address and network, and then destination IP address and network, and then condition, and then port number or name. So if you put TCP, we could do like 22, as we did before with SSH. The condition and port number specifies a criteria for traffic ports that we wish to match. So you see permit, TCP, any network, and then this is a condition. So it could be equal, established, greater than, less than, not equal to, or range. And then if we just say, like, that's for the simplest example, equal to, then we could put in our actual port number, or we could put in special words that correspond to things that Cisco knows about. So for example, Telnet uses port 23, so we could just put Telnet there so that we kind of know what we're trying to block. It's easier to read the ACL, but we could also just put 23 just so that we know it's actually port 23. But Cisco includes this in case we don't know the ports for certain services, and so that it's much easier to read the rules and know what happened in there. You can also add the established flag at the end to match only traffic for connections which have been established. Remember the whole TCP three-way handshake thing? So you can say you only want to match traffic that is established already. It already went through that TCP three-way handshake. Now for every entry into our extended ACL, all conditions specified in the rule must match for traffic to match a particular rule. So as we build longer and longer commands going this way, you get more specific. So for example, this one is TCP, permit TCP any EQ something, right? So just as an example, if we put EQ telnet here, a TCP flow that is SMTP or SSH won't match this rule because we have that EQ telnet there. If we didn't put our EQ telnet, then we'd have just have permit TCP any. So any TCP flow would have matched that. But because we limited it and we put a bigger filter on it saying EQ telnet or EQ23, then only traffic that is TCP and matches this network and this network, if we put in those networks, and is going to port 23, will match this rule. So it has to match all of those connections to be considered a match. Remember, we can also add remarks or comments to our ACL, but they do not show up in Packet Tracer. So I didn't talk too much about the remarks or the comments because when I tried it out in Packet Tracer, it wasn't showing up. But in the real world, you want to put as many comments and as many descriptive stuff in the ACLs as you can, because what will actually happen is you'll develop an ACL, today, and you might build 10 or 20 or 100 rules in the ACL, and it might work after however much troubleshooting, it will work. But then in a year, when you come back to the ACL and you need to change something, you won't know what's going on. So these remarks and these comments could really help you understand. You might say, we need to block all ICMP traffic that is not within our network or is not sourced from our network to protect our management devices or management for our devices. And then you see, 10 rules that enforce that. So you have some context to it. So using extended ACLs, we can create large, complex ACLs. It's a bit overwhelming, but that's because of the power and flexibility of extended ACLs. So I know with extended ACLs, you're going to be lost, right? I still very lost with a lot of these rules, and you only get familiar with it when you start using it. Which is why I tried to keep these commands as simple as they could for extended ACLs. But you can't grow and you can't get as fine-grained as you need to. So extended ACLs could be used, for example, if you only want to permit TCP from a particular network to another particular network destined for a particular port. With a standard ACL, you couldn't do that, right? You just didn't have that amount of control. So with the extended ACL, it becomes a lot more complicated, but it also gives you a lot more flexibility and power. So this is just an example of what a real-world extended ACL might look like. So you see IP access list extended from DMZ. So a DMZ is usually a place where you'll put your servers. It's a demilitarized zone. And then you'll see, okay, remark responses to HTTP requests. So this is a comment that we put in to help us understand what's going on here. Permit TCP from this network that is www to any network established. Okay, permit TCP from this network that is equal to 443 any established. So for those of you who know web servers, you might immediately say, okay, this is clearly traffic that is from an HTTP server, right? So you have the www and the SSL or the secure HTTPS requests, and this allows traffic for those things. And then we go again, ICMP and DNS, and we keep going like that. And then at the end, we have our deny IP any rule. So we constructed this list to allow certain services that we want or that we expect to be needed on this network, like TCP for our web servers, ICMP so that we could ping our web servers, UDP and TCP for certain networks. Well, I'm not sure what was the domain or DNS, right? That's kind of weird. We obviously want to allow DNS to and from our web server, and then you have more HTTP requests here for different networks. Oh, no, it's just different things there. But yeah, and then we want to allow all of this and then drop anything that doesn't match this. So it makes sense, right? This access list clearly being used to protect web servers in our DMZ, and it's very readable because of these remarks. So you see it's kind of long, but if you take your time and read through it, you'll understand what the extended ACL is doing. So don't forget to apply your ACLs. Even when you construct that big ACL, you need to link it somewhere. If you don't actually link your ACL anywhere, the rules aren't evaluated ever. So your ACL isn't actually applied until you apply it on an interface. So if we apply extended ACLs in the same way as standard ACLs, using the command IP access group and then ACL name or number and then in or out. So interface GI01 IP access group from DMZ in. So that was the name. That was the name of our ACL here. We just put in IP access group and then the name there and then in or out, depending on the direction that we expect packets to flow in and the direction that we filter in from here. So we need to look at the how we build the list and the direction that we expect the packets to go from and make sure you're putting it in the correct direction. We can troubleshoot both our standard and extended ACLs in the same way using the command show IP access lists. So you see show IP access lists and you see a list of all our access lists. Standard IP access is 1, and then we have a rule permit this. Then extended IP access list from DMZ, and you have a rule like that. Extended IP access list from outside, you have a rule, and we go down. So these are all the access lists that we create and all of the rules inside those access lists. So we can review the access list here. Note that every entry or rule that we add to the ACL gets a sequence number prepended to it. So that's the numbers here, right? You see the increment by 10 automatically. When we put in a rule, every new rule is incremented by 10 from the last rule. So if we didn't put in this, just as an example, if we leave out this deny IP any and we kept building this, the next rule would be 100, and if we put in our next permit TCP whatever, it would go to 110, and then our next permit or our next deny would go to 120, and it would keep going like that. And the whole reason for this space in between the numbers is to allow us to change rules, right? So if we want to remove this rule here, we could put in 21, and we could say 21 permit TCP 10.2.0. whatever, and it would come after that and before that. So you see, we could put it before a certain rule or after a certain rule. We have that space and that flexibility because of this default incremented by 10. If it used to increment like 1, 2, 3, 4, 5, 6, then we wouldn't be able to move around our lists, or it will be a lot more difficult to move around lists as we wanted, right? We would need to go on like take 5 and then renumber it and put it as 10 and then put in a new 5 and all kind of madness. With this, we could just go and put in like a 25 or a 26 or a 27 and we have a lot of flexibility there. We can override the number at the start by putting the number that we want in the rule. So if you just put sequence number and then you permit deny IP address, whatever. So if you put 25 permit TCP, whatever, you get it in between there instead of appending it to the end of the list as it would be by default. So just a note here, as this is a full list basically, and you have that deny IP any, which is like a deny all rule. If you put in something like permit TCP 10.0.3.0 here, nothing is ever going to hit that rule, right? Because it's going to come down here and reach this, and always it will match this because this is deny IP any. So it's always going to match this and then go out there, and it's never going to reach that rule below. So you need to renumber this now and say, okay, 99 permit TCP 10.0.3.0. So it will go before this deny IP any rule. Remember that packets are processed immediately when they match a rule. So the order of our rules is extremely important in ACLs. We may need to use these sequence numbers to reorder our rules if we want to ensure that one rule is matched before another. Yeah, so I hope that makes sense. So this was, let me see, right. Yeah, okay, so it's just two examples out here. So this is an example of how to renumber your ACL. So you see I have show access lists here, and we have the default behavior, which is 10 permit ICMP any, 20 permit UDP any, 30 permit ESP any. Right? These things are very flexible. We can put in a number of things here. But the important thing to note here is that we increment it by 10 every time, right? If we don't actually include this number, it will just look at the last number and add 10 to that, and then put that before our number. So that's great. But if we want to put in our custom number, we go IP access list extended test. So you see test there. And then 15, permit TCP any. So you put in the 15 there, so we expect it to show up here. And then you do a show IP access list test, and you see 10, 15, 20, 30 now. So you see it shows up there as we expect. Instead of, if we didn't put this 15, and we had just put permit TCP any, it would have been 40, permit TCP any. And then the order would have been off there. So once we have correctly applied our ACLs, we will begin seeing counters at the end of every rule as traffic matches these rules. This is a good way to verify that our ACLs are working as intended. Note that our implicit deny rule at the end of the ACL does not show a counter. It is often a good idea to include an explicit match all rule or an explicit deny all rule at the end to ensure that you account for all traffic. So you see, show IP access lists. So this is the command that you're running to see these matches, right? So show IP access lists, and you see your matches here. 20 matches, 9 matches, 3 matches, 4 matches, 3 matches. So this is basically telling you this ACL was applied correctly. We had 20 packets coming in and 20 packets match this rule, or maybe 100 packets came in and 20 packets match this rule. For this one, it's okay. Yeah, for this one we could definitely say we had 9 and 3, 12 packets came into this rule. 9 match this one, 3 match this one, and none match this explicit denial rule here. Because this is an explicit rule, right? This first one, there is no explicit rule. So a lot of packets could have been matching that kind of secret denial rule at the end there. But with this one, we have an explicit denial rule. So we know nothing has matched this, because it would have shown up here and say 2 matches or 3 matches or however much. Same thing with this one. We have an explicit rule. Nothing has matched that explicit rule. So we know all the packets that came in match this or this or this. And we know how many packets match this. So just as an example, if you lose connectivity as soon as you apply ACL and you want to know which rule you got wrong, you just do a ping or you do some kind of test to generate some kind of traffic, and then you look at these counters and see which one increasing, so you know exactly which rule being matched. Of course, ACLs are not only limited to IPv4. We can also create IPv6 ACLs using the command IPv6 access list and the ACL name. Note that all IPv6 ACLs are extended ACLs, and we cannot number IPv6 ACLs. Once we are inside our ACL subconfiguration menu, we then enter our entries in the form permit or deny, protocol, source IPv6 address and network, destination IPv6 address or network. And for TCP or UDP traffic, permit or deny, TCP, UDP, source IPv6 address and network, destination IPv6 address or network, and then the condition and the port number or name. So basically the only difference here is that we do have standard ACLs for IPv6, and then we obviously replace the network addresses from IPv4 to IPv6 networks. So this is what it looks like. For IPv6 access list, my IPv6 ACL permits IPv6 any. So instead of permit IP any, is permit IPv6 any. But TCP and UDP obviously work the same. Permit TCP any EQ www. Just as an example. And to actually create it, we go config T, then IPv6 access list, and the name of our ACL. We could put in remarks if you want to comment anything, and then deny TCP, and then the network, and then the network. So there's the source network, there's the destination network. Deny TCP, source network, destination network, source network, destination network, and then permit IPv6 any, or deny IPv6 any, whatever you want to put here. So the difference there is we basically move from IPv4, well, IP by itself, to IPv6. We replaced our IPv4 networks with IPv6 networks. You'll see we have no wildcard masks here, because we don't have wildcard masks in IPv6. We have a whole prefix here, so /64. But the EQ and the ports and everything stays the same, and the keywords stay the same. It's still permit or deny or remark. And we apply it with the same method. No, actually the method different here. Do I have that here? Anything I need? Oh, yeah. Nah, I think I need to pay an explicit one for that because I wanted to take a note of that. Is IPv6 traffic filter, and then the ACL in or out, not the command you're using before. Let me see. Where was this? All right, so you see IP access group, and then the name and in or out, and there's IPv6 traffic filter, and then the name and in or out. So I need to add that in because I put it in the screenshot, but I didn't paste in the actual let's put like a little note on it. So this is how you actually apply IPv6 ACLs. Instead of IP access group is IPv6 traffic filter, but then the same thing with the ACL name and then in or out. So you get in IPv6 ACL and the name, and then you put in all the rules just like before, and then you exit out of that and you go int S000 and then IPv6 traffic filter and the ACL name and then in or out. And then to check our IPv6 ACLs, we use the command show IPv6 access list. So show IPv6 access list, IPv6 access list, and the name of it, and then all our entries. And of course, we'll see the match rule at the end of it if we have traffic going through it, just as before. Right, so I wonder, okay, before I start this, give me 5 minutes, and I get some water, and I want to add in this thing before I forget. So we'll come back, let's say 7:05, I'll start back.